Uh, we're going to do something a little bit different. This might be more advanced than you're wanting to participate in. But what we'll do is we'll create a gear in using a gear generator program, and bring it into AutoCAD, convert it to a polyline, and then export that polyline over into a 3ds program so that we can make a model of it and then print it as a 3D model, as a 3D piece of plastic. So here we go. The first thing you do is you find a gear generator, and there's several free gear generators online. I recommend that you offer some money to the persons who create them, because they're really kind of neat and they're very efficient. So here's one that I use. This is a little program called Gear Generator, and as you can see, it starts out with a couple of gears doing all kinds of meshing and rotating and stuff. You need to get a book on what gears. There's certain engineering aspects to gears that you really should learn, but regardless, you don't really need too much background on it. In this particular little gear generator, this is called Gear Template Generator, and what we want to do is we're going to try to get it down to where we have just one gear. And so there's certain things that we don't want to see. We don't want to see anything but the gear. We don't want them animated, don't want a grid, and we definitely don't need a second gear. So we're going to not show the spur gear. We're just going to show the big gear right here. And you can see over here that we've got certain aspects. How many teeth are in the gear? How big are the gear teeth? Tooth spacing is real important. What kind of measurements are we using? We can go up here to units and switch it over to inches, so we can at least have some sort of we could use millimeters or centimeters, whatever. But I'm familiar with inches since I live in the United States. Now I'm just rolling my mouse wheel, and okay. And I'm making the gear diameter change. You can see that change happening down here. How many teeth are showing up down here? So we've got something that we can work with. This shows 14 teeth. Shaft spacing is 5.491 inches. How big is that shaft? Let's look at spokes and more. The shaft hole is a hole 1 inch in diameter. Oh my gosh. My printer would never handle that. We're going to drop that down. You can see I'm working down here in this corner. Let's go with something like let's go with a 1/4 inch, 0.25 inches. That works a little better. And you can see how tiny that hole is. That's a 1/4 inch hole right there. So this is a gigantic gear. And what we want to do is bring this get back here to gear properties, and the tooth spacing, you can see as I change that how the teeth drop. And here we've got tooth spacing of 0.3 inches with a 1/4 inch hole. That's not too bad. That's a pretty good little gear right there. And then shaft spacing, as we change our shaft spacing, you'll see our tooth spacing changes. So we went back to 0.3 inches. That's easy to remember. And shaft spacing just pretty much stays the same. We've got 14 teeth, 0.3 inches. That's the distance from the tip of center of one tooth to the center of another tooth. And a 1/4 inch hole. Okay, that would make a pretty good little robot gear. And just for funsies, we'll go ahead and accept that gear. But there's other things that you can do in here. You can see this thing will make chains and sprockets. It'll throw spokes in there if you have a big enough gear. But our gear properties right now are 0.3 inches, 14 teeth, a 1/4 inch hole, and the addendum is a 1/4 inch. Addendum is the length of the gear teeth. You can see if this changes, you can see our gear teeth kind of creep out there and get pointy, and if they bring it back down, they start flattening off on the top. I like flat top. So 0.3 for tooth spacing. We're going to use a 0.3 addendum, 14 teeth, and a shaft hole of 1/4 inch. Something to remember. Now, what we have to do is export this as a basic DXF. Don't try it with the polyline, because apparently this program kind of plays around with different kinds of polylines. I haven't really been successful with exporting as a polyline, but as a basic DXF drawing. And you can see it'll give you various others. You can go with a PDF or HPGL. I just use basic DXF. And it says, where do you want to save it? And I'm going to put it up here in our little program where we've been playing around here in our screen capture projects. And we'll call it Gear 14. It'll tell us 14 teeth. And how do we want to save it? We'd like to save it's going to, we have no choice. It's going to save it as a DXF. So there we are, Gear 14. Now we're pretty much through with this program. Gear 14 DXF is in our save box. Now let's go back to AutoCAD. And here's our AutoCAD program. We're going to file, open. We want to keep this drawing. It says wheel and hub. We're going to keep that drawing open. We're going to open another drawing, and it's going to be, we have to ask for DXF drawings. And there it is, Gear 14. Open up. There's our little gear. And you can see it's down there at the center point of the drawing. But here's the problem that you're faced with when you import these things. Look here. You see these are individual, very short, just lines. If we look at the properties, we're going to see that these are just lines. And there's a whole bunch of little bitty ones, you see, that are scattered in there. We got to turn this into a polyline, one big polyline. So let's go PE for polyline edit and pick on some straight line, and that way you're only picking one. And yes, I do want to turn it, hit enter, and I want to join everything. So hit J for join and then select everything. But look here. Now we've got a polyline for our outer perimeter, but look, our circle is a whole series of little short lines. And that's not going to work well for us. So this is what I do to locate the exact dead center of that. I just draw a straight line. I pick a point that's approximately dead across, and draw me a little line that gives me a place that's got a center. And then I could just get rid of all these little short lines. And then I draw a circle, starting from the center to the point. There it is. Get rid of that line. And then I check it. What's the diameter of that? And it says the radius is 0.125, diameter is 1/4 inch. So there's my hole. Now it's a circle. It's not a bunch of little short lines, and this is a polyline. Now we have something we can work with. What we can do, if we want to import this into our other drawing, we can, but we can save it right where it's at as Gear 14. We'll just save it, File, Save. It's going to be a DXF. That's okay. Our program works with DXF. And save, and there we are. Now we have Gear 14 as a polyline and as a 1/4 inch hole. All right, well, we're through with this. We can minimize it. And Gear 14 as a drawing. And it looks like we've got it this time. That's a polyline. Let's activate our sketch and click on both of these. I held down my shift key so I could click on multiple parts. Control C. You'll notice that when I'm working with these drawings, since I've done everything in AutoCAD, all I do is hold my control key and copy. That's it. I'm taking that drawing out of here and I'm putting it over in my new part. And file, new part. And it'll open me a part window. I can click, remember we have to click on a plane, activate 2D sketch, and away we go. Now I can paste, Control T, and there's my circle just perfectly set right in the middle, snapped right to it, because it's a polyline. Now what we can do here is we can just do a simple extrusion of these parts. And let's say that I want to go there, I'm going to go to extrude, and the thickness of this part, it'll be a 1/8 inch gear, 0.125, and hit OK. And there's our part. We now have an 1/8 inch thick gear, and our 3D printer can print that just fine. If we want a locking hub in this, that's really not much of a problem either. We can create that locking hub right here in our 3ds program. Go back to sketch and see, we can pick up a circle. We're in sketch mode, and we'll snap right to the middle of that. And we go out here, it says 0.556, but we can type in, I've let go of the mouse, and we can type in 0.5 and hit enter, and it'll give us an exactly 0.5 diameter little hub, or hub reinforcer right there in the gear. Now then, if I want another hole right here, click on here, drop it dead center, and you can see it'll snap. I just let go of the mouse and type in 0.25. And now I've got two holes, two circles rather, ready to be extruded. But you must remember, in this case, I did not create an extra plane to be working right on the surface here. Instead, I'm working on the back surface of that gear. If I want this hub to come out here, I'm going to have to get it out more than 1/8 of an inch. It'll have to be something like, let's pick 3/8 of an inch. And so we go part modeling, and that'll give us a 1/4 inch hub sticking out on this side of the gear. And I just hit extrude. And you see my little arrow in there is pointing out from the back side. And I print 0.375, 3/8 of an inch, and hit OK. And there's my 1/4 inch. Now what if I want a little, a centering hole, or a little guide hole to put a screw or a pin through? I can click on to this little plane right here. You notice I'm not clicking on the back plane, I'm clicking on the YZ plane. I could click on this one, it wouldn't matter. But I want to see it from the side angle. And I hit activate sketch and watch. Boom, there it is. Again, I can still go right, I'm just guessing that this is going to be about in the center of that. And then I have a circle, as you can see. I'm just leave my mouse alone, and I'm going to type in, something like 0.1. Sounds good. Diameter. And hit, and there it is. I don't like it being that close to the gear teeth. I'm going to back up. I'm going to say, no, I don't like that. I'm going to try again, but this time I'm going to be a little further out, away from the gear face, and I'm going to type 0.1 again. And, it wanted to jump back in there. What's going on? My snap is on. That's what's going on. So let me back out and turn my snap off. Now I can get a circle and put it anywhere I want. Put it right there. I want 0.1, and there it is. But what good is a circle? I need a hole, so that's not a problem. I just go to part modeling again. This time I'm picking extrude a hole. Remember, cut, remove. I'm removing material, extrude that, And again, if I only wanted it out one side, I would just let it punch out one side. But in this case, I want it through everything. So I go through all. I go, okay, there it is. And there's my locking pin hole for my gear. Now I can lock the gear to a shaft. See there? Got a 14-tooth locking gear shaft. And when I print this in the 3D printer, that hole will be accurate enough. It'll print it, of course, from this flat face here up. And that flat hole, that hole will not be perfect, but it will be good enough that it'll guide a drill bit straight through that little arm there, or that little hub. And now I can lock that gear onto my hub. Hubs are always stronger if you get rid of this little spot right there. You got to get that little 90-degree section there filleted. And so what we're going to do is we'll use fillet. And you see fillet, remember it always starts up with a 1/2 inch fillet. Now we don't need anything that dramatic. We're going to go with something small, just enough to guide the stress lines away from that hub. So we go 0.04. And we pick that little spot right there. Maybe lose it. There we go. Wow, look at that, 1/2 inch. 0.04. Not on the face. That's crazy. We picked that blue face. We got to back out of that. I'm going to close that. We don't want that blue face. It will give us fillets all the way down our teeth. So we're just trying for that line right there, fillet. And that looks pretty good. 0.04 and apply. And there's a nice little fillet around that hub. Now we have a pretty smooth little gear. It would work great. I've built many of these gears into little machines that I've made, and they work just perfect. Especially if you got your 3D printer set up right, so you don't have to do too much cleanup afterwards and get too many fins off of them and stuff. There's your gear. And that's how you do that. Thanks for watching.